Hello and welcome to my PHP Data Access Library comparison. I have created this table to put various ways of simplifying database access side by side and go in great details to identify which headaches you could avoid if you use a certain database access pattern or library. Now, I'm not solely focused on ORMs. There are multiple ways to perform database abstractions. Different libraries do it differently, and the syntax is slightly different. And I'm okay with that. So syntax doesn't have to be compliant to whatever, but I will be looking into different capabilities that those libraries offer out of the box, and how it can help you in your application development. And my primary focus with ORMs is to avoid mistakes, keep your data layer separate from persistence. So your field names doesn't, for example, in here, field names doesn't have to correspond to the database names. If you're looking to add your own or update some of these comparisons, you're most welcome. But please listen to this video and I will go over the sections to explain what all of these things actually mean. So you're not misrepresenting your favorite framework or whatever. Okay, so to start off, I have created this gist over here. It should be linked from the description. And I'm starting with a very basic definition of three entities. We have client, and now each client have multiple invoices, and each invoice have a bunch of lines. A very simple structure, anyone can visualize that. Now they are related to each other, so the invoice, for instance, has a client and only one client. We call it one-to-many relationship. Client can have multiple invoices. This is one-to-one, right? So one invoice has one client. Now, if you look at the client side, then one client can have multiple invoices. So we call it one-to-many relationship. The many-to-many relationship is a loose term. So first of all, can your ORM represent multiple clients? And if it can, then can we map multiple clients to all their collective invoices? And we'll get to that in deep traversal section, but for now let me jump into the persistence definition. So what is persistence? It's some sort of a layer between your business logic and a specific database, and in here I'm using one layer which maps my entities into SQL. So that's a pseudocode, right? So it's not representative of any framework, it's just for illustrational purposes. And as well in here, I'm not sure if that syntax is possible in PHP, but I just wanted to show that there are some types involved in there. Okay, and then we could also say that instead of storing my model inside SQL, I want to store it in array, MongoDB, or maybe even a JSON string like that. So going on over here, the transparent integration of NoSQL data engines is ability to still rely on things. For example, over here I have a code like load user, and it will load user by a specific name. So it will search user by the name of John. But the thing is that this method should work with the user model regardless of its association with either a SQL database, array, JSON, MongoDB, and so on. So it should work with a consistent syntax across all of these persistence. And this model over here, it also should be of the same class. So okay, and also looking in here, like so, same model, multiple persistences. We have defined one model for the user, but we can use it with the multiple persistences. So that's an illustration for this one over here. Not many ORMs can do that, but it's a pretty cool thing. So it allows in your application. So if you decide to shift from one persistence into another, even for specific like model. You don't want to shift the whole database, just one model. It should be doable, right? Like that. Okay, next is vendor-specific extensions. Now, NoSQL databases come with a lot of things. For example, MongoDB comes with a pretty interesting aggregate extension, which allows you to like build a pretty complex aggregation procedures, what I call them, and the domain code, like utility code, should be able to recognize if those vendor-specific capabilities exist, either through something like that or through a different way to detect things. And if they are supported, then the code can make decision to use them, and in an alternative situation, it can branch out and do things in a more or image style way. So like, this will take more CPU, and this one will execute stuff on the server. But the point of this method is that it will work so it has a fallback. So it will work with any given persistence. In some cases, it will use a more efficient implementation, and in other cases, it will have to emulate this in over here. So that's vendor-specific extensions. Okay, next we're going to mapping, and mapping is basically ability. So let's say you have a code, maybe you have developed an add-on which works with users, orders, whatever, but in your specific implementation, when user is stored in this particular database, you want to change the name of the table. So instead of just called users, it will be called app user table. So the important thing to know is if the model is if you can associate the same model with multiple persistences, can you define the name of the table or collection or the file or key inside the array based on some of your internal logic, and then make the whole ORM respect that. So in this case, we are changing the name, so the name will represent a column called full name. So even though my business logic is still relying on name, whenever I'm issuing save, it will go into the database and update the full name column. And as a domain developer, for me, it doesn't matter what column, what is the name of the column in the specific persistence, because all I care is about the property name right over here. So that's table mapping and field mapping. Okay, the next thing is, can entity be mapped to a subquery? And the use case is simple. So let's say I have a user, but it's not represented through a table. Instead, for example, I need to run a custom query. In this case, I'm using a call to store procedure, and it will provide me with the actual data to use in the model. It could also be a subquery, even potentially a different entity, but for this particular point, like mapping to a subquery, can ORM operate with something other than the physical table? Okay, native field mapping. That's probably this one. So map native types. Okay, so essentially, if our model has a date type field, then loading it would be in a SQL. It could be represented as a string, but your ORM layer will make some decisions based on the configuration or your time zone settings and convert it into the datetime object, which is more native to PHP. Okay, so that's field type mapping. Okay, and then the next one, user-defined types. So what if I want to create some sort of like my own type? For example, I'd like to have a field which contains both the amount and the currency, and when it's saved, I want to define my own rules how this thing will be saved into the database. So can I do that? And in this case, it actually stores in 2 fields, but you could do some other stuff like serialize it or do something else with it. In case with databases like Mongo, sometimes you'll create an array or like like a sub array which contains the values, or maybe like a associative thing. How do they call it? Hash. Yeah. So you can create a hash for the total which contains those 2 fields. But with SQL, it might be something different. So it makes sense if you store this separately, because you can do some sort of conditions, but needs to be abstracted out. So as far as the main logic is concerned, you just storing the amount with the currency and with the number and the currency, and it's getting saved somehow. So that's user-defined types. Next one is map field to related entity, and essentially we're saying that one of the fields inside invoice, when we're loading an invoice with a single query, that's important. So we're loading invoice with a single query, but actually it also picks up the name of the client, and it could be accessed like this, which many ORMs follow, or it could map into a different field like a client name. But the name of the client should be accessible for all the invoices. So if I'm exporting list of invoices, I would expect the name of the client to be there, like auto field. Again, it needs to work across different persistences. So if you're dealing with MongoDB, then the underlying logic might be different, but will it be transparent? That's the question. Subquery on related entity. So in this case, we're loading the invoice, but this time we're interested in the total of all the lines. So if you look at the example over here, then there is actually total for every single line. So somehow it's expressed, and all we're saying is that this invoice, this total, shouldn't be a physical field. Instead, it should be sorted through a subquery based on a relationship between the invoices and the tables. So when I'm loading invoice 25, the total of all the lines belonging to this invoice will sum up and will appear in this field automatically. So no physical field. I'm not talking about hooks, and every time the line is added, the invoice is updated. That's a different pattern. So in this case is a subquery. So subquery on related entity. Okay, the last one is ability to join multiple tables into a single entity. And the scenario here is again quite simple. So let's say we have a client, and there are 2 fields. One field is being name and another being address. But when we save, the data is persisted into 2 different tables. One table is called client, and it holds the field for the name. The other table is called client address, and it holds the address for some of the clients. And those tables would be linked to each other somehow, and I don't care how, because I'm focused on the domain logic. The entity is stored in those 2 tables. I will have to define this relationship as one of the persistence rules, but the ORM should deal with that automatically. The same should apply when I'm adding a new entity and deleting entities. So it should respect that entity is actually stored into multiple tables. The next pretty big thing, which many ORMs don't bother to implement at all, is called criteria. Criteria is something like a where clause, but it's global, and it is applied on like a top level of the model. And probably the best example of criteria, or could be called scope or condition, is soft delete. So when you implement soft delete, so let's say client is a model whose entities have to respect the soft delete clause. So when I'm trying to load the client number 2, if it has been soft deleted, the record shouldn't load. It's marked as deleted. It should behave as a deleted record. Again, it needs to be done transparently. It's a persistence related feature, soft delete. So that's essentially our scope. So the model won't be able to load some of the models, and soft delete is over here. Now user can also define some criterias. For example, can we define a VAP client that will automatically set the VAP flag to yes. So every time we add a new VAP client, it will make sure the VAP is 1, but also if I'm trying to load VAP client, it will only let me access the VAP clients. Another example would be the user and then having an admin flag for the users. So can a model represent the admin, which always have the scope. So that's that's the definition of the scope. And the main point of the scope is that you don't have to define it every time. For example, it could be it could have several conditions, like VAP is 1, deleted is 0, which is automatically applied. So developer can't make the mistake of forgetting some of those conditions when loading stuff. Criteria compliance. That means that adding a new record must match record criteria, and in this case I'm still working with a VAP client, but if I do specify that the VAP is false, this record will fail to save. So this would be like some sort of a guard against creating incompliant records through my model over here. Okay, then the next step is expression conditions, right? So condition doesn't always have to be a static value. So for example, the condition over here, I don't know how different database libraries will define that, it's up to them, but I want to make sure that this particular model can only access records inside client whose name equals to surname. Okay, so if I'm loading the record number 2, it will only load if name matches the surname. It could be other conditions, for example, age is above 18 or something like that. But this is expression conditions where something becomes more complicated, not like VAP equals false. In some scenarios, this could be pretty complex. So it could have a call to a stored procedure of some sort, just pretty much anything. And finally, we're looking into dynamic conditions. So yes, you can probably define some conditions on the level of class, but the class is not aware of what's going on. So in this scenario, let's say I'm working with accessible order over here, but it has a dynamic condition which is added into that depending on which user is logged in. So if I'm logged in as a user 39, then this condition will automatically be applied to every order I'm trying to load or create. And that ensures that user with ID 39 will not be able to access any order by other user or create any order by other users. So that's a dynamic condition or dynamic criteria. And so I have reached like a halfway of my explanation. I had recorded another video to go through the rest of this. Okay. So anyway, thanks for looking into my comparison, and I hope if you have some knowledge of some of these amazing database access frameworks, please feel free to adjust them. I started doing it myself, but I'm not expert in all of them, so I'm relying on your help to fill it out. Thank you.